Moving on, I'm going to be introduce yourselves to Mario Carrasco Brevis. Mario has been with Goldfields since 2020, and he's currently the senior mine planning engineer. He draws experience from 5 years in copper mining, 5 years in gold, block cave and open pit, in operations both in Australia and and overseas. Short and sweet. Welcome, Mario.
Anyone here knows how many decisions we made every day? Well, based on a Harvard Business Review, we made 35,000 decisions every day, of which 95% are subconscious decisions. Now, if we think about the 5% that we made decisions consciously, how many of you have been in the situation when you just do something because has been always do like that, or because it works? Of course, we are missing a lot of good decisions to be made in all this process, and there are tools to avoid this one, right? Risk assessment in operations. You have a lot of tools in writing about the ideas, decisions, etc. And I want to show here how MindMax has helped us in Goldfields to avoid this kind of bias that all human beings have. So my name is Mario Carrasco. I work in Goldfields as a senior planning engineer, and I will talk not just about MindMax in a theoretical perspective, but also I'm going to show the Gruyere case and how we were implementing MindMax in this open pit mine. So a little bit of Gruyere, medium-sized open pit, gold. There's some numbers there. Somewhere in Western Australia we are 5 diggers plus 5 diggers plus 530 trucks, some stages, some capacities. I'm not going to go into detail because that's not the purpose of this one, but just so you have an idea of the problem that we are going to tackle here. So now that's the context of the mine. Now jumping into the context of the strat plan that we run in Goldfields. Probably all of here have been involved in this process before, and everything starts with block models, parameters, assumptions, etc. Then we run with some macros, we import in some softwares, and then we get the ultimate pit limit, right? After we run Lechant-Grossman or pseudo-flow or whatever algorithms you want. But we in that step we already defined what we are going to mine, right? And then we change the problem into how we are going to mine it, and that way include time in the problem, right? And that's a scheduling problem. And that's when MindMax comes into the game, and when we start get into some scheduling problem. And the first step is a stage design. So what's the best stage design that we can create for get the best NPV possible? What's the best mine capacity? What's the best mill capacity? And these are the steps that we are going to be covering here with MindMax. Then I add another step here that are the options that MindMax solves really well and allows you to assess more complex scenarios that we usually are able to do. And then finally you have a plan, right? So this blue circle is where we are going to be aiming with the actual presentation for MindMax implementation. And yeah, the question is, what's the optimal combination? And that comes in this actual active mine. And first, then we have to validate all those results that we have been carrying over from previous years. And it's related with what we have been doing, and we do just because we have been doing in the previous years, or how we change that mindset. So let's jump into this stage design validation. First of all, MindMax doesn't generate the stages, so it will do the best with what you put into the software, right? So in this case, we have plenty of design options, and we just select the 5 best ones. And then we, as all mine engineers, we have the traditional isolated ways of validating stages, right? We start looking the distribution of the ore tons in the stages, the distribution of the ore, of the ore grade and stripping ratio and the practicality of these designs, right? How they marriage between them, how these shapes, corners look like, and then we have like a kind of expert assessment of the designs, and isolated, right? And then what about the NPV, right? How is going to be looking the blend of these stages? How is going to look the stockpile usage, and eventually the risk? How reliant we are going to be in the plan with the stockpile that we have available? And then I'm going to show you what, in terms of not in numbers, but in qualities of the assessment. So the first 5 blue columns are the traditional assessment for each stage, and on the left you have the 5 best design sets that we were able to find. And then in the last 4 columns we have some variables from MindMax. Of course, there's plenty of variables that MindMax can give you to assess the designs, but these were the main ones that we were concerned for this project. So how reliant is the plant on a stockpile, and how is the stockpile consumption? We are consuming in 1 year 2 million tons of stockpile, or we are going to have a smooth vector of a stockpile balance across the life of mine. And of course the NPV, that's relative to the maximum NPV that we were able to find there. And all these analyses get us to the set 5. Of course, it's not the maximum NPV because we have this engineer perspective of the problem as well, right? It's not about numbers or just optimization or theory. And then if you put all these or mining planning 101. So we put all these designs, the design that we select in the exposed O graph, you can see straight away the problem. So for those that has not been too familiar with this graph, you have the time on the x-axis, the y is the tons, and each color represents a stage. The bars are ore, and the lines coming from the bottom are waste. So you can see when every stage expose the ore in what time of the period of the life of mine, right? You can see a stage 4, the light blue, gets open in, these are months, basically after the first year, and then you have some periods, and then it depleted, and then you have, it's not a specific place, right? You have a period that you don't have any ore available. So for those that are not familiar. So you can see the problem straight away on this graph, that you are relying basically on stockpiles, and that's a very risky plan. And that comes with other problems, that you are losing value, you have a risk, and you name it. But you don't want to make this plan to get this plan to operations, right? So you have to work in something. And of course you have the best case, or the thing that we want in the circle, in the green circle, that is when you overlap the stages, right? And you have overexposed from 2 stages at the same time, and you have flexibility and reduce the risk. So you are losing value, you are having risk, etc. So we need to do something. And I will take advantage of all the mine engineers that are here. What do you think that will be a good option here? So maybe you can tell me something that we were not thinking in Goldfield. What do you do here? There's no wrong answers. You can say reduce the mill capacity. Anyone?
Bring in a contractor.
Increase mine capacity, right?
Could you look at smaller stages or the width of
Redesign, yes. Other? Well, that are the main ones that we thought about it, and are the more logical ones. So we have increased mining rate, and I'm going to meet the redesign, because as MindMax doesn't do redesign, I'm not going to talk about it, but we are working on redesign now because of this as well. And add another source of ore. That will be another option. And luckily, we have another ore source there in Gruyere. So that are the hypotheses that we have. We can improve the plan, by doing this. How we validate this hypothesis is where MindMax helps us to do, and it's very quick and flexible. So first, let's flex mine and mill capacity simultaneously. So basically, we have the base case in MindMax, and we just clone it and just change the capacities specifically for each combination that we want. And then we export it, and we have this value surface graph, right? NPV surface. And we are in that red point somewhere there, and we want to move into the green point, right? Because we increase the value. And basically, that direction is increase the mine capacity. So basically, here we are validating that the mine capacity increase will improve the NPV. And eventually, I'm not going to show the or expose the graph, but reduce the risk of the plan and allow to rely less on the stockpile. So MindMax was very flexible and agile in doing this. Was very easy. Each scenario probably will take half an hour. And so how many scenarios we have here? 4 times 3, 12. And we run also these 12 scenarios for different bench turnovers or vertical rate of advance. This is the 10 bench per year. So run one with 8 or 12. So we have 36 scenarios, and that will be running easily in 1 day, 1.5 day. So from one day to another, you can have all these surfaces. And are very handy because it's easy to explain to someone that is not used to see kind of this level of decisions, right? I assume that everyone understands this surface, right? Where the mine rate goes, where the mill rate goes, and where the value goes. So right, we have validated the mine capacity increase. It's the best option to go. And now, additional ore source. What happened when we add additional ore source in this surface? The same exercise was repeated, but now with another option to add Golden Highway, that is the other source of ore that we have very close to Gruyere open pit. And the surface change, as you can see. And now it's not so clear that the mine rate increase is the best option to go. You can see also that there is another option to increase the mill, but that will increase probably the risk of still relying on stockpile. So there's things that you cannot, you need to think about it. You still need an engineer here, right? So yeah, this validates also the decision of adding a new ore source will increase the value of the asset and reduce the risk. And that's, I don't want to say this, but it was the easy decision to do, right? We have already the ore source there. You have to start with the feasibility studies or whatever, and you can just cover all this risk and increase the value. On the other hand, increase the mining rate was more difficult because this pit is very well known that has a very narrow area to put more equipment or include another contractor, right? So that's why the redesigns come into the table again. So it's redesign basically or add another source of ore. So the same. Yes, the same. MindMax has been able to validate this one very quickly, flexible, and the more important is easy to communicate. Yeah. And now, yeah, probably didn't mention this before, but the mine planning process is a circular process. So, and this can be easily seen here because we added another ore source. But what if now another set of design is better with this new condition? So then you can start jumping again for the first step, and that will be not difficult to assess from a MindMax perspective because you already have all this set up, right? It's just add this ore source for all the stages that we were assessing. I'm not going to show this now, but yeah, because of the time. But it's not difficult to do, and that's basically the circular nature of the mine planning problem. And MindMax covers very good this area. And then someone, yeah. So yes, now I want to jump into the options. So for those who don't know what an option is the right but not obligation to do something. But so when you go to the market and you want to buy a chair You have a price there, right? Though you can also have an option to buy that same share into the future at a different price. So if you know that the price is going to go up, you probably can buy the option to maintain the actual price. That's what basically the option is. It's just buy the right to do something in the future at the conditions that you decide, right? So that same concept can be taken into mine planning because it's a decision. And how we assign a value to this option is how we make the best decisions. So let me put that in Gruyere case. So we have 2024, Gruyere is normal, 2025, Gruyere is normal, and then in 2026 onwards, so can be 2027, 2028, you start having the option to do something that has been what we have been talking before. Increase mining rate, add another source of ore, do nothing, maintain the actual situation, or stop mining. So this is what the options are, and MineMax handles very quickly and in a way to assess this. So you can see here I put each option. I want to read everything. Option A is increase mine capacity and add another source of ore. Option B will be just add another source of ore for 30 million. Option C will increase the mining rate by 10 million tons per annum at 10 million capex, or 20 million tons per annum at 20 million capex, or 30 million tons per annum at 30 million capex. Option D is do nothing. Option E is finish mining. So when you put this in MineMax will decide what is the best option to go. And not just that, it will tell you when will be the better timing to trigger that option. And all these focus on NPV. So I have a lot of experience, but I haven't seen any software that can do this. Usually what you do is just run all the scenarios and see what is better, as I showed you before, just this NPV surface, and see, okay, that's the best option. But if you do it like this way, you just need to run one scenario, right? Because it's going to tell you what is the best direction to go straight away. So this is very powerful in terms of what we are talking now, because the decisions can be informed decisions, and it will not take too much time to have a proper scenario to back up that decision. So if we run the scenario with no capex constraints, option A is triggered. Of course, you increase the mining rate and you add another source of ore. That will be the better for the plan. Now, if we add a constraint for the capex to be expended, because we don't want to be above a specific all-in cost, for instance. And if we spend more than 30 million, we are going to be above the 4,100 gold price that is now. We just triggered the option B, that is include another ore source. So this is basically making compete the decisions for money. And this is very relevant as well, because imagine that you can do this with different assets. So you have an underground mine in South America and open pit mine here, and the question is where I will put my money to have the better return, the better NPV. And that is basically what it's doing. It's making compete the money. So you can start seeing here that you start looking very complex problems that you cannot solve like just thinking or talking with someone. And if you do, probably are not the best options. Best decision. So MineMax will help a lot in this ambit. And doing this, you don't have to run the 36 scenarios that I told you before. You have to run one, but you have to be aware of how you set up this stuff and understand. You can run the 36 scenarios to show that to something, and show that surface that looks more friendly to someone that doesn't know about this. And then I start to wrapping up. So let's think backwards. So what the best plans need to have from a strategic perspective? It needs to have the mill as an active constraint, right? It needs to have a proper blend. The stockpile usage needs to be smooth across the life of mine. You don't need to rely too much on the stockpile because it's risky. etc. Right? The mine the same. You need to consider bench turnover, mining rate, equipment hours, rehandling, control all these variables. In terms of option, the capex, the timing of this capex execution, the costs, how fixed and variable behave during the life of mine, the all-in cost in our case, etc. So all these variables basically can be controlled within MindMax and are very easily defined, and you can create custom reports, and I think that they are improving a lot the reportability, right, as Chris showed us before. So MindMax, you can start saying that MindMax doesn't include this or this or this, but this is strategic level. And as I say there, all models are wrong, but some are useful. And there are some models that are very useful as MindMax, I will say. So yeah, and now going into the conclusions. So MindMax has proved to be an agile and robust tool to assess the strategic scenarios that we want, and more important, validate the hypotheses that we think that are the best option to go, and then back up the decision that we do, right? All strategic variables can be visualized on the go. You don't need to finish a scenario if you're running. You can see straight away the results period by period. And at the same time, it can be controlled. You can pause and run and change parameters, etc. And the more important that I found also is that this exact methodology, if you share this model with someone else and it run it will have the same result. And I cannot tell this for another software that I have seen in the market and I have used for these kind of problems. And that's a plus because you can talk the same language with other person without having any confusion. You can validate the options and all the hypotheses and more complex than you usually do. And of course, all this process, all this options, setup, validation of the hypothesis allows to break this because it works. So this has been always made this way. And I think that that's a big issue. What I have seen in where I have been. So yeah, and finalize, MindMax allows to reduce the time of setting up things. It gets a more dense cloud of results that will allow you to back up a lot of more scenarios and take more informed decisions. And that gives you at the same time more time to analyze and take those decisions. That's a thing that I have there.